Hello, it's Miss Huser, and today I'm just going to be going over some notes that I put together as a nice review before it comes down to you guys working on the review. So basically, I took the outline of all the concepts, and I just made some problems similar to the test on this notes. So just go ahead and follow along. And honestly, if you think that you can pause and work ahead on some of these, go ahead and do that, okay? Alright, so just a little review on our exponent rules. So we have power of a power, so I'm just going to list all the rules up here. So say we are multiplying with like bases. So multiplying with like bases, you add the exponents. So there we go. So there's an example for that rule. If we have power of a power, we will multiply. So think of if you were to see a problem that had 2, 4, think about what would you do there. Hopefully you're thinking multiply, and you would, and you'd end up with 8. So think of this parenthesis there as a sign to multiply. Alright, now let's say we are dividing with like bases. That means we will subtract. And I'll change it to that to make it more obvious. We'll subtract, so we'd have x to the first power or just x. Now if we have negatives, that means you'd flip or write the reciprocals. So say we have x to the negative 4th, that's the same as 1 over x to the 4th. If we have 1 over x to the negative 4th, write the reciprocal. We have x to the 4th. Okay, so that negative sign isn't saying anything's negative in value, it's just telling you to flip or write the reciprocal. Okay, so here are some examples that are similar to the ones that will be on the final. Right here, power of a power, multiply, so that'd be x to the 24th. Alright, now these, if you want to pause and then try and do them and see if you get the right answer, go ahead and do that. But here we go. We're dividing with like bases, so you subtract the exponents. So we'd have x to the 8th. Just kidding, that's an m, but still, sorry. I got the variables mixed up, my bad. Okay, now this last one. There are a few different ways we could handle this. Since we have negative exponents, we could just rewrite this with those in the flipped in the as if they were a reciprocal. So I'm going to do that first. So we'd have 3x to the 8th. And right here, that y to the negative 4th, I will bring that down to the denominator. Now down here, there's a negative. So I'm going to bring that to the numerator. So I'd have x to the 3rd over 9. And then I'm going to have y to the 4th and y to the 2nd. So I just flipped these two because their symbol said to. So now, whenever we have coefficients, you can just reduce using the operation that is given. So right here we divide, so we'd end up with just 3 on the bottom and 1 up top. You don't have to write that one, but I have it there just to show. Oh, sorry if this mouse is on. Okay. Now we are multiplying with like bases, so that means we can add the exponents. So we'd have x to the 11th, and then same concept down here, y to the 6th. Alright, now the other way we could handle this is we could just kind of reduce and do the rules right away. So 1 over 3, we're going to simplify. Now right here, we have 8 minus a negative 3. So that's the same as saying x to the 11th, and it's going to go where the larger exponent is. Or in this case it is, okay? Now the next one, negative 4 minus 2, so that would give us a y to the negative 6. Now since it's negative, we flip it down to the bottom, and there we go. Same answer, just two different ways. I think it's easier to move them than simplify, just because dealing with the negatives can kind of be tricky. But there we go. Alright, now this next section is Pythagorean theorem. Pause it and see if you can remember it and write it down. If not, I'm about to. So a squared plus b squared equals c squared. Now c is the longest side. AB does not matter, okay? It's also diagonal across from 90-degree angle. So right here, it's across from the 90-degree angle. That means that is our C value. Also, you can tell in this one it is the longest value. Same with over here. It's across, therefore that's the C value, and we have that there. So what we're going to do is label our side lengths first. A and B does not matter, but since those are not the longest, we know that these will be A and B. And then we're going to find C. So now we're going to plug these values into the Pythagorean theorem. So we would have 5 squared plus 15 squared equals C squared. Now we can simplify. 25 plus 225 equals C squared. Then we have 250 equals C squared. And we want to know what C is, so we have to take the square root. So we're going to square root both sides, and C equals 15.8. Alright, now I want you to pause and try and do this next one on your own. Okay, so this is A, B, and C. Does not matter if you have A and B flipped. So we'd have 5 squared plus 14 squared equals C squared. So 25 plus 196 equals C squared. We end up with 221 equals C squared, square root of both sides, and C equals 14.9. So there will be a problem on the final where they give you a shape, and you'll have to label the sides, plug them into the Pythagorean theorem, and call it a day. Now this one, you will have a word problem as well, so this is good practice. A cat was stuck in the tree. The tree is 15 feet tall, so here's that tree, and this is 15 feet. Okay, there we go. Then there's a ladder that's 20 feet tall. How far away is it from the tree? So here's our ladder, and that's 20 feet, and we want to know what this distance is here. Okay, so first off, we need to label. This would be A and B, and here is C. So now we can go ahead and simplify. So we have 15 squared plus B squared equals 20 squared. 225 plus B squared equals 400. Subtract 225, and we get B squared equals 175. Square root both sides, and B equals 13.2. And there we go. Alright, any questions? Probably not. Okay. Of course I have it. Okay. Another bullet that I don't have examples on here, so I'm just going to wing it. So say we have a graph that looks like this. You need to tell, is it a function or not a function? If you have a line, what you're going to do is your vertical line test. It hits it at only one spot each time, therefore, yes, it's a function. Now I'm going to show you an example of a graph that is not a function. Let's do this. That's fun. Now let's do our vertical line test. Oh no, it hits it twice. So that is not a function. Alright. Also, so you'll have to determine that off of a graph. Also, just given some values. So, just a important thing to remember is each input has only one output, which is the same as saying one Y value for every X value. So there we go. So say we have an example like this. Make those all negative. So right here, these are inputs and outputs, X and Y. So let's say if you plug in a 1, you only get a -3. Okay, so there we go. If you plug in 1, you get 1 output, so that's good. Plug in a 2, you get 1 answer. Awesome. Plug in a 3, you could get 2 different answers. So that means it is not a function. Now, if each of these only had 1 output, then it would be. So there's that. Alright, now here we're going to go over some polynomials. So just adding and subtracting. So right here we're subtracting, so what I'm going to do is switch that to addition and then flip the signs. Alright, now let's see. 10 to the a to the 5th. I'm going to find its like term, and it's a +2. So we'll have 12a to the 5th. Checking those off. Awesome. Now I'm going to go in order of exponents. So right here, -8a to the 3rd. Do I have a like value over here? No. So this is just going to stay -8a to the 3rd. Next, I guess, would be this one. And over here we have a like term of -9a. So I'm going to combine those and get a -14a. And then lastly we have +13a to the 2nd. Now, is this in standard form? Are these going in order from greatest to least in our exponents? Not quite. So we're going to rewrite this. And there we go. So that is our answer there. Now this one, I forgot to write all the questions. So what is the degree? I'm going to pause and write all the questions out. So you will have a problem that asks you these different questions given a polynomial of some sort. So right here, these aren't the best order, but let's start off, is this in standard form? Yes, it is. Okay. Now, let's see. Okay, now let's see leading coefficient. So that would be the coefficient that is at the front. Therefore, it would be -3. Now it says how many terms. Well, terms would be, they are separated by the addition or subtraction sign. So those are each individual terms. So we have 3 terms. And what is it called when we have 3 terms? Well, that is called a trinomial. And then degree, that is the highest exponent. In this case, it is a 3. So that would be cubic. So there we go. Alright, now down here. You will need to probably refresh yourself on these different names because you will have a question like that. This one, simplify. You can use box method, FOIL, or whatever you prefer. I'm going to go ahead and just do my work, and then you can check and move on. I use FOIL, so I'm going to do first, so 3x squared, outer, -9x, inner, plus 2x, last, minus 6. So then we would have 3x squared minus 7x minus 6. And there we go. And we stop there. Next, we're going to factor completely. So whenever you're factoring anything, is there a greatest common factor I can take out? Yes, I can take a 3x out. Alright, so we'd be left with 3x squared plus 2x minus 5. So you're going to do the AC method. So multiply the first two, -15. Bottom is 2. And so list off your factors, and you end up getting +5 and a -3. Okay, so just always double check yourself. Do these add up to equal the bottom? Yes. Do they multiply to equal the top? Yes. Be careful with the signs. There we go. So now we'll rewrite this as 3x squared minus 3x plus 5x minus 5. Greatest common factor is a 3x. So we'd have x minus 1. Over here, greatest common factor is a 5. So that'd be x minus 1. Now at the end, can't forget about that guy. We'll have 3x parentheses 3x plus 5 and x minus 1. You will get counted off if you do not bring that down. So please do not forget about that. There you go. Alright, now this one right here, same thing. You're going to use the AC method. So I want you to pause and try it on your own, and then I'm going to do it. Okay, now here we go. AC method, 32 and 12. List off the factors, and you end up with 8 and 4. That will work. So we'd rewrite this as c squared plus 4c plus 8c equals, not equals, plus 32. My bad. Now I'm going to take the greatest common factor out. That would be a c. Over here it would be an 8. And c plus 4. And then our answer would be c plus 8. And then c plus 4. Once again, I'm not going super in depth because this is a slight review. So if you are going to need more help on this, please just come to one of my help sessions this week. But there's that. Don't know how far along I'm going to get in class, so I'm just going to do one more page and then call it good for today. Okay, so given a graph, you will need to figure out what's the vertex, the y-intercept, and the x-intercepts. So right here, my vertex is either the highest point or lowest point. So in this case, it is -1, 9. Now the y-intercept, where does it hit the y-axis? Right there. So we would have 0, 8. Your y-intercept is always going to have an x value of 0. Okay. Now our x-intercepts. That will be -4, 0, and then, so right here, and then 2, 0. Now on the test, I will give you a reminder, but it might just give you an x value and have you plug it into a box there. So you'd have -4 and 2. Okay, so I'll give you guys a heads up before the test, but that is something you'll need to be careful about. Okay, now down here, graph the following. I want you to try and do that first, and then we'll check. Okay, so first thing we're going to do is find our vertex. So what we're going to do is opposite of b over 2a, a and b. So we would have opposite of b would be a +8 over 2 times 2. 8 divided by 4 is 2, so our x value is 2. Plug in 2 for x to find y. So we end up with y equals 8 minus 16 plus 4. So our y value would then be -4. So the vertex is 2, -4. So that is the first thing you'll do if it's given to you in standard form. So we're going to go ahead and plot that. 2, -4. There we go. Our a value is positive, so we know it will be going upward. Now we can find our y-intercept. So to find our y-intercept, we plug in 0 for x. So y equals 2, 0 squared minus 8 times 0 plus 4. So our y-intercept would be a +4. Now this is where you graph your line of symmetry and reflect the point over that, and you end up with your graph. And there will be a graphing calculator on the final, but that is just a good refresher. Horrible drawing on my end, but that is a good refresher over that. And there you go. That's it.